सर हम लोग कार्टेल नहीं बना सकते अगेंस्ट कंपटीशन कमीशन ठीक है नहीं just going to answer your this thing. Every company have different way of it. There are certain people who might add up into their material and then they will show you service as a smaller portion, right? And there are people who don't add up into the material, so the service portion looks bigger. It is about each company's their own strategy, right? उसका चालाकी रहता है, बस उतना ही है. वो किधर से किधर पैसा डालना चाहते हैं, क्या करना चाहते हैं, उनका है. इसलिए आपको भी कभी कभी मैंने ये भी देखा है आजकल कुछ टेंडर्स में आता है आपका सर्विस पोर्शन मिनिमम इतना % होना चाहिए, क्योंकि कभी कभी सर्विस है ना बहुत कम प्राइस बोलता है मेरा 5 साल के लिए, तो ओवरऑल प्रोजेक्ट कॉस्ट में इट इज लेस देन 5%, राइट? एंड देन व्हेन यू आर कॉलिंग व्हाट हैपेंस, यू हैव ऑलरेडी पेड 95%. ये 5% नहीं चाहिए, द वेंडर कैन वॉक अवे, right? At least for the industry sake, there are nowadays I see a lot of things where the service portion they say that minimum 20% it has to be there. ओवरऑल कास्ट में 20% भी नहीं रहेगा तो 5 साल कैसे चलाएंगे, और उसका रिप्लेसमेंट आपको लेके आने के लिए भी वो पैसा चाहिए ना. सर मेंटेनेंस टॉपिक अगले प्रेजेंटेशन में आएगा, उसमें डिस्कस कर लेते हैं. बट स्कैटरलाइट as a technology which we had discussed in the earlier seminar also, right? What we are doing is even a smaller volume is more than sufficient to measure, because what we are talking about is a homogeneity at that measuring topic, right? If you have a good homogeneity, then even a small portion of your sample is representative of it. So you are measuring a small volume, it is sufficient. You don't have to measure the whole stack or whole portion of that stack. What Roland wants to say is, when you have the particle sizes, very high particle sizes, because of mass is corresponding to the particle size, right? Bigger the particle size, the higher the mass. So the mixing of it might not be very good. But when the particle sizes are lower, let's say the new ESPs, the particle sizes are less than 4 micron, right? It's less than 4 micron. So you have a good mixture of it. And as and when it further comes down, the particle sizes are very smaller, it becomes PM1, then it more or less behaves like a gas. So they have a very good representation. Right, Roland?
Sir, I
Yes, sir. It has to be that way. At least I am an old school guy. So I also feel like until I don't go to the site, even visit the site, understand your philosophy, then there is no point in giving you a solution. Because otherwise what will happen, I will have a different assumption. Let's assume that you are from one industry. I will have some assumption of another industry and I will give you a solution. That is where we enter into problems.
If there is some changes in the atmospheric conditions or the parameter, then also suggest the vendor or partner that we correct our registration technique.
Yes, sir. Possible. But then that is where we work like a partner, right? When we talk on behalf of all the vendors, why the suppliers out here would like to work like a partner, and you also has to select a partner is you don't have the headache, or you don't feel this as an headache for you rather you feel as part of your whole ecosystem. That is the only topic, sir. Thank you.
गाइडलाइंस पता चल कि एक SOW and SLA will be fixed for
सर
some
CPCB का
standard,
मैंने कुछ एक्सपर्ट्स दिखाया था ना इधर,
some standards.
उन्हें बड़ा गाइडलाइन दिया हुआ है,
Okay.
उसका रिवाइज गाइडलाइंस भी आया हुआ है, उसी में उन्होंने इंडस्ट्री वाइज क्या क्या टेक्नोलॉजी यूज कर सकते हैं, इंडस्ट्री वाइज क्या क्या गैसेस है, और वेंडर के साथ आपको कौन सी टाइप की एग्रीमेंट 5 साल का ACMC बनाना चाहिए, वो सब भी उन्होंने रिकमेंडेशंस दिया हुआ है, बिकॉज ये लीगली तो एनफोर्सिंग नहीं हो सकती है, बट देयर आर रिकमेंडेशंस. And anyhow, we industry are not buying only SEMS, right? As an industry, we are buying so many.
There is any check with the CPCB for final recommendations?
Sir, responsibility industry का है, CPCB का नहीं है.
Okay, thanks.
Recommendation. सर एक चीज समझ लेना है, whatever you do not do, final responsibility lies with the industry. If the data is coming, not coming, anything, the responsibility lies with the industry. इसलिए टॉपिक वही है, आप वेंडर चूज करेंगे तो ज्यादा ट्रबल आपके ऊपर ही रहेगा. पार्टनर वैसा पहले से क्लियर कर लें आपका क्या रिक्वायरमेंट है, तो और इजी रहेगा.
Sir, sometimes we are facing unit shutdown and internet connection problem in the industry. So it is excluded from DCR in terms of SAM, because we need 85% DCR. So we are facing this kind of problems like internet connection is off and unit shutdown. So
सर साहब बैठे हैं.
oh, actually sometimes we email email ID erc.appc.
You don't have to mail any information, you don't have to post anything. Okay, you just fill information in workflow. If you feel that our plant is shut down or there is some problem, maintenance problem, or anything, you just fill. So that thing is taken care when we calculate, when software calculates percentage availability of data. Okay, so that is very well taken in our software. Okay. No issue there.
Thank you, sir.
I think, Prachir, will you elaborate this thing? Yes, percentage availability.
उस केस के अंदर में सॉफ्टवेयर में एक प्रोविजन है कि आपको एक पर्टिकुलर एरिया में जाके जो वर्कफ्लो हम लोग कह रहे हैं, वर्कफ्लो में जाके अपडेट करना होता है कि आपका प्लांट जो शटडाउन होने जा रहा है उसका ड्यूरेशन क्या है. अगर आप उस ड्यूरेशन को मेंशन कर देते हैं तो ऑटोमेटिकली रिपोर्ट्स के अंदर में शटडाउन लेके आता है. तो शटडाउन जब लेकर आएगा तब उसको आपका अवेलेबिलिटी ही काउंट करते हैं. तो आप इंश्योर रहिए कि अगर रिपोर्ट में कहीं ऐसा दिखता है कि 15 दिन शटडाउन है, 15 दिन वर्किंग और अवेलेबिलिटी 50% आ रही है, तो आप इंश्योर रहिए वो आपकी 100% ही मानी जाएगी. नहीं, अभी जैसे हम लोग जो सिस्टम में काउंट कर रहे हैं, अभी सिस्टम के अंदर में ये प्रोविजन हमने अभी रिसेंटली स्टार्ट किया था कि शटडाउन जो है आपका अपडेट हो रहा है, राइट. तो उसका जो कैलकुलेशन है वो अभी नेक्स्ट मंथ से इंप्लीमेंट हो जाएगा, तो आपको दिखने लग जाएगा. पर हम लोग जो कैलकुलेट कर रहे हैं अवेलेबिलिटी, वो हम लोग उसको काउंट करते हैं शटडाउन को. तो सिस्टम की साइड से, हमारी साइड से कभी उसको लेकर कभी कोई लेटर नहीं आएगा, कोई ईमेल्स नहीं आएंगे. सिर्फ शटडाउन को हम कंसिडर करते हैं, बाकी चीज आपका प्रॉब्लम है, दैट यू नीड टू टेक केयर.
तो वो ऑफ कोर्स वो डिलेड डाटा में आएगा आपका, वो डिलेड डाटा में आएगा.
Yeah. And there is also a possibility whenever internet connection is not there, the local data acquisition will keep happening and you can backfill the data. That is also possible. So it is not that today internet connectivity, even if it is not there for 15 days, you have enough capability storage in your IoT device which is there, and when you get the internet, it will immediately backfill the data.
Sir, a workflow provision is applicable for shutdown.
Have you ever seen the workflow? So आपने उसमें एक पूरा लिस्ट देखा होगा.
Yes.
There are number of lists, like there are 15 or 16 incident जो आप उसको select कर सकते हो. Shutdown, for system, for another fault, internet down, camera down, everything is there, right? So you can select anything. और उसका time period आप डाल दीजिए. If it is a fault, you can take a tentative date, right? कि वो 30 दिन के लिए system fault में गया हुआ, another fault में गया हुआ, you can give the tentative date. हमारे पास information रहेगी your system is faulty, so whatever data is coming or if it is not coming because of this reason, right? लेकिन data availability count नहीं होगी उसमें, right?
We also have a session for presentation. What we are doing is MCPC. So we will explain all the things. Also that what he is checking and you people are getting caught.
Yeah.
So
Very hands-on is available on day 4, right?
Okay. Thank you.
Thank you.
चलिए वो थोड़ा पर्सनल गप चाय के साथ करेंगे. पर्सनल वाला चाय के साथ करेंगे. Then you can certainly discuss. These are important things, but I will have those points as well. So there are vendors here, but I still would like to convey to you, when you are buying equipments for any process and it is also important that you ask questions to the vendor. That I need these kind of things, how will you do this, how will you do that? If you are asking questions, you will be aware, you will be safe. If you say, you give me the solution, I have raised my hand, so then there is always a chance that you will not get the right thing. So you you need to have some knowledge, and you need to ask the question to vendor as well. So let's go to say PM SAM's fundamentals. I'll say a little bit about the technology, and then we'll move into the operation and maintenance as well. So I'm going to cover PM SAM's technology very briefly, their fundamentals, how you select it. About the installation, there are other presenters which are coming. They will also cover that point. So we'll focus on operation and maintenance as well. What you see here, emission. So what we see in emission, mostly primarily we figure it out dust, right? So that's how. So it is not the new thing that we are monitoring. We are monitoring it for ages. Still, one of the most difficult monitoring is PM. It appears easy, but it is the most difficult part. Selecting, monitoring, as well as then calibration. We started from here. In the early days, we had a Ringelmann scale where we used to have a scale strip with the different colors, and we used to see the smoke with that, how dark that smoke is, matching with that strip, and we are saying this much is the opacity and that's the pollution level. We moved from there to this. So we had a pump, and we used that pump to draw the air from the stack, and if you see there is a filter paper slot, and after certain gas which is sucked in, the paper used to give this kind of level of grace, so it was used to say that how much is the pollution, how much is the opacity. And that we used to consider as a dust monitoring. Fast forward to today's life, we reached here. So where we have automatic monitors or SAMs. So we have different types of SAMs, you already know. We install cross duct, we install from one side. We will get into the detail. Now we use this to have the data on real time. And we use that data. It is being used for quite a good many years. We are using it now. Still we have multiple problems in it. Most of the problems are related to PM monitors. Right from the selection, again then the correct installation, operation maintenance, and then getting the data and normalizing it. Overall, if I divide the PM SAMs, you can broadly have two categories. One which works on the optics, light, other on electromagnetic, that is triboelectric, AC or DC or electrodynamic you can say, or beta attenuation, yeah, that you already know that you use, ambient air quality monitoring system. That's the technology. We mostly use this one. And all these types of variations, technology, advances works on this. What you see here is light is coming from that end. This is the fundamental of entire functioning of a PM monitor. Light is coming from that side. There are dust particles which goes into the stack. What will happen? Some of the dust will get absorbed or reflected. Some refracted. So what will have? The amount of light given from this side will not be the same which is coming from this end, which is you have a receiver. So what happened? Some light got lost, extincted. The extinction of light is the opacity. So what we read here is the loss of extinction of light. That is the opacity. So here the limitation here is, if you have high dust concentration, then what will happen? Much of the light will get emitted, refracted, absorbed or reflected. It will not come this side. So the difference of the light extinction, light given and light taken, you will be able to figure it out. That is why opacity monitor is used for when the dust concentration is higher. It can clearly say this is it. That's the basic fundamental. What next? Some of the light is coming this side, scattered forward side. So the fundamental is that you have a monitor which will monitor from here. What will monitor? Is light scattered in forward. So this technology is forward scatter. So usually how we see something, if an object, there is an object, what we see? Some light goes on that object, reflects back, comes to our retina. More of the light comes to your retina, you can see it clearly. Normally, more of the light comes from this end, so it is that you can observe, you can monitor clearly. So even if their dust concentration is low, forward scatter can monitor you better. What happens next? Some of the light which is reflected back. You can also monitor the back light which is scattered back, that is backward scatter. The difference between forward and backward is less light goes into this. That it means you need to have higher concentration to monitor that concentration. So the thing is opacity, which is extinction. So it is used to monitor when you have higher dust concentration. When when you have a lower concentration, 30 milligram, 20 milligram, what is the base for? Forward scatter, because it can monitor to that limit. In between, you can use the backward scatter. So this is the overall funda of PM monitors. You can select, there are other variations, size of the diameter of the duct, if it is higher, you can go to little lower. We'll get into the more detail. So the opacity, it is also called transmissometry or the transmittometer. That is what I said, loss of light extinction, loss of light, that is the extinction of light is PM monitor. We'll not get into the detail, you can easily find on Google and all. I'm just trying to explain and get you the idea of that. There are variations on it. So what you saw, light goes, extinction of light which is received from the receiver end, and you get to know what is the opacity. Variation in that is, now the few monitors you have seen, that is the standard. One side is the light source, another side is the receptor. Variation of that is, what happens, they put a reflector here, so light goes to this side, reflect from that, and again the monitor that side. So it covers two ways, twice. It can give you better result. It can give you, talk about the alignment as well. Another variation of it is two beams. You have seen one beam of light, one beam crossing twice, double pass. Now there another variation is two beam. Both sides you have a light source, both sides you have a detector. So you can see the better alignment itself. Everything has a pros and cons, but these are all the variations. Opacity meter suitable for medium to high concentration. If you have a 20 milligram and all, I would suggest that that's not the right equipment. Normally we have a higher dust concentration. So for that, 50 above 100, perfectly fine. If you get lower than that, better to get into the back scatter. If you are pretty low, you have to go in forward scatter. Low concentration needs longer measuring path length. So that's what I said. Technology, you know what are the range, but if you have that low, in some of the cases, if the diameter of the stack is big, you can monitor little lower range. But beyond the limit, it will not be able to figure it out how much light has been extincted if the dust particle is very low. Well, ultimately, the fundamental is light has to reflect, go back and lost. If the light is pretty low, you will not be able to figure it out the difference. So it's better to choose the right technology. All these technology which works on the optics or light that can be affected by moisture droplets, that is affected by the particle sizes, different types of particle shapes, sizes, refractive index, etc. But normally in our power plant or in any industry when we combust, it's a kind of mixed particle. It's not like we get a particular type of particle going through. So that may not be much of the problem, but it affects when you have ESP or working on certain efficiency and all. But largely that is not a particle size and mix and is not a problem because we do have a mix of that all the time. Calibration instrument response design changes with the particle type, refractive index, but it doesn't vary. You cannot get into that much of detail. If you cover the overall funda, higher concentration, again I am saying the opacity, lower than that, back scatter. If you are pretty low, then you go for forward scatter. And if you have to measure the lower concentration, You can play with that depending upon you need to have the larger diameter of the stack. Smaller diameter you cannot cover the higher lower concentration normally. Another variation of transmittometry or opacity meter is scintillation. There what we have seen, we saw that the light is going, it is extinction of light is covered. This technology works out when light goes, falls on the particle, it gives it fluctuates or it flickers. And the another end, that monitor reads that and gives you the value. Not very common in use nowadays. We are mostly having opacity or going to the scatter. This is not very common in nowadays. This is the scattering which we already normally use. So that's what I had discussed. If you see the scattering that I saw, that the profile is being shown. If you see in the forward, more of the light, backward, less of the light. So this is how it is working. And all these things happen when you have a monitor in this portion. This is where you monitor. You do all this kind of scheme. Forward scatter, as I said, better sensitivity, suitable for low and medium concentration. This low and medium is for Indian conditions. It is not low and medium for European because there it is 5 milligram, 2 milligram, we cannot even think about that. So we are talking 20, 30 like this. A small scattered light intensity requires high measurement accuracy. That's what we discussed. Occurring at small angle to the incident. So properly shielding of receiver from the direct sunlight is crucial. Air purge is required. So as you were asking that cleaning, etc. For any optical instrument where you have lens and all, cleaning, maintenance, etc. is required. If it is covered, you have a trouble in the reading. It is required, irrespective of how advanced technology you have. Backward scatter, that I said, suitable for higher medium concentration, little higher than the backward scatter. Calibration is affected by the particle size again, that's the basic thing. More sensitive to the changes in the particle composition and refractive index. And response reduces by 20% from peak if particle size changes by just a micrometer. Because its sensitivity is little lesser than the forward scatter. So if the size and all changes, it gives a different response. Water droplets is an enemy for all the monitors which works on the light or electrodynamic. This is the one thing that you are going to face pretty soon when you have a FGD. This is extractive type. Scatter we learned, forward, backward. But when you have FGD now, wet type or seawater, moisture content will certainly increase, temperature will go down, you will have running water in that. That you saw one of the example in this stack. What will you do? The monitor that you have already installed, many of them had asked the questions. The monitor that you had installed, opacity, forward scatter, backward scatter, will not work. So they have a new work orders ready. Not today, but tomorrow you have to ask them for new one. There are other variations, but then that if fluke duct is going, temperature is already 130, 140 or more than that. You may need take a portion of the gas and use for reheating of the gas after FGD, so that temperature goes up and there is no water droplets in that. But that is again changing in the operational system. Nobody would like to prefer to make a system in that or reheating that system again. That's another energy cost is one of the bigger concern. So in that case, you have to have this extractive type. What is happening here? The red line you see. So sample gas is taken out. It is heated in that thermocyclone or vaporizing chamber. Literally means that the water droplets which is there, it will get into becomes vapor, not in the droplet form. It will be monitored in the scattering technology. Normally it is forward scatter. It is monitored and then the gas is discharged. So once gas is out, again there will be water and all. It is thrown out again. So this is the technology. Now the cost is, you have entire heating system outside. You have a forward scatter. All these arrangements of pump and all heating and all. So of course the cost is, I believe 4 or 5 times higher than the forward scatter standard. So you might need it. I said might means of course you have another choice, but you need to have this kind of system once you have FGD in the place. this one you might have come across in the beginning, TriboFlow, or triboelectric you might have heard. Basic fundamental of it is the specific type of probes which is in the stack. Dust particle which goes up through the flue gas, collides that and generates a charge. That charge is multi-amplified and being read and given it to you. Normally this is used as a back filter leak detection. It is used right now, but because of its function, it is used in monitoring as well. It is sensitive. There's a debate on this. It's a AC or DC type. Another variation of it is electrodynamic. It is being said that when you have electrical equipment for pollution control like ESP, so the dust might take some charge and you may get misreading. But it is also being said, we have been discussing last few days, that after certain distance, covered 8 distance or 8D kind of distance, the charge may not be that much effective. But another part of the dust in power plant, you know that we have a certain good amount of resistive duct, which is not being captured in our ESP. Now the problem is if that dust is coming, it is not carrying any charge. It is not being captured in the ESP as well. That is why it is resistive. That Indian coal has this kind of property. That is why our emission is higher. So one that doesn't have any charge, and even if it collides to that specific rod, it may not generate a charge, right? Because of the particular dust quality. In that case, emission has happened, but you do not have any reading. This is also sensitive to the flow variation of that. If flow is higher, you get higher reading, or so mostly suitable for if you have a stabilized flow. So there is a limitation with this. Cheaper, so it is preferable in many of the plants and people use it, but it is sensitive. Another variation of it is, and for the water droplets and all, it is again same, it is not giving the wrong result. Another variation of that is electrodynamic. The probe here has a specific covering. So what happens when the dust carries some charge, it passes to it and it reads it. It's a kind of variation. It says that because of the specific covering, it is not being affected by the charge or affected by the moisture also. I'm not very much, I don't have much confidence on it, but it is said that it works better than the triboelectric or triboflow. Zero and span, etc. is not possible in these kind of equipments. These are certainly cheaper than scattering ones. This you already know. It is being said that beta attenuation is one of the continuous monitoring, but it takes longer time. How does it work? You know that you use this technology in ambient air quality monitoring, right? You collect the dust, collect the flue gas, it passes through a specific tape, dust is settled, there is a light source, beta radiation source, which goes on the dust. You know that in radiation, it takes radiation and then it leaves again. So when it moves another round, it lifts up that radiation and that is being read and it says how much. But it takes time of 4-5 minutes, so it is literally not a continuous monitoring, but it is one of the part. It's being considered that it's unlike the gravimetric, but this is one of the monitoring method. We normally use it in ambient air quality monitoring. Based on this technology, I just have this matrix. You have the similar kind of matrix in the guideline as well. So if you see, what are the main parameters we consider when you have, of course, one is stack diameter. You need to see, ideally, you have a probe which reaches to the center of the stack. It is not very much essential, but ideal to have. If your flow in the duct is homogeneous, you understand it is laminar, homogeneous, and perfect, you can have the shorter one, but ideal is that. So stack diameter, concentration, as I said, you have to understand what is your normal concentration of the emission. Based on that, you can choose the monitoring technology. APC device, that is, if you have weight type, if you have a cyclone, back filter and all, it also affects the performance of your monitor. So you should also have to see this. These are the dry, humid, wet. What is the gas condition? That's what I said. We had a weight extracting nowadays. So we must see which one is suitable for you. Based on this, I just try to figure out, just think about the thermal power plant. What we spoke, that's where we can find a ideal condition of the selection of the equipment. If you say 0 to 20, which is pretty low range, what is suitable, most suitable one? Forward scatter, right? You can have, if 0 to 50, backward scatter, forward scatter will also work. 0 to 150, opacity, and backward can also work. So this is how you understand. This little bit of your knowledge is also important when you buy the equipment with a vendor. So you will have all these slides for sure. But all these monitors, when you install, when you run, what does it monitor? It monitors extension of light, it monitors light response to the light, but it is not monitoring dust concentration, right? It is not monitoring the milligram normal meter cube or milligram meter cube or ppm. But how would you know then that what is milligram? Light extincted or light captured, but what is milligram? How it is connected to the milligram? That is why we do the calibration. So in calibration, what we do? We have a monitor installed, SEMS installed, it is giving a reading to you. At the same time, we do the gravimetric monitoring. Gravimetric means the manual monitoring we do. So you know that for the particular condition, you have a reading in SEMS, milliampere or whatever electron volt, whatever we do, depending upon the technology. And at the same time, you know how much dust you have got, milligram, meter cube or milligram nanometer. So you know this much of milliampere or this much of SEMS reading is equivalent to this much of milligram nanometer cube. That is what the calibration. More of the reading we take, 9 points, 12 points, and based on that we make a chart, and then you get a K factor. That K factor is used in the formula, and that is what you put in your software. So that is how we use gravimetric monitoring, and gravimetric monitoring gives you the reading in milligram normal meter cube. We have a specific session on this. Gravimetric monitoring, which we use for calibration, is one of the most complicated and one of the most important part of the life. So we have a specific session of entire 1.5 hours. We will do here, there are set of calibration, how we do calculation, how we calculate, what all things we do. We will do here as well, and then when we go to the plant site, he will show, that person will show with the equipment, this is how it is done, and you calculate. So I am not going to focus more on the calibration part. This is one of the things about the maintenance. We have some universal fact is, when you have any kind of equipment, not one of the same. Manufacturer, when it gives you the detail, operation and maintenance in manual, we must follow that because it has been tested. It is saying that how much time it will take for your usual maintenance time, how regularly you should do, what precautions you have to have. So the operation maintenance manual of the equipment is not a joke. It is based on the performance and the use of that equipment. So you must follow that. Ensure the consumable, whichever is required for that particular equipment, you have on the site. It is not like that equipment consumable is gone, then you have given the order, and so 3 months data is not there. So then it is your fault. You should have consumable on the site, spare parts in stock, option for remote maintenance in case of the vendor has that kind of facility who can, because many of the times we find that your site is too remote. It is not feasible to go in a day or 2 days or just on call. So many of the vendors, I have seen the facility, you communicate with them over phone or online, they guide you, you do this, you do that, and they can do. At least you can continue the working of the equipment. So there is a facility, you can certainly check with your vendor or technology provider. Zero in span check is about the sensitivity. We always talk about, we did calibration. What did we do in calibration? Zero in span. Zero in span is not the calibration. We discussed this yesterday. A lot of tests are required. It is part of an O&M. So zero check is required. What is the interval of zero check as per the guideline? What is interval of span check? Weekly was in between, but now it has the revised one says fortnightly. So I have already given an answer of one of the question in assessment. So, and for that, in PM case, with built-in test window, test light sources for light transmission, scattering instrument, these things you can use. You can do zero in span using electrical simulation in case of electrodynamic equipment when you use. Operation and maintenance of optical PM monitors, frequent cleaning, so it is required. It also depends upon your experience, depending upon the dust concentration in your stack. You know how often your lens gets covered or you need cleaning. It is not like the fundamental, it is fixed that it will take 15 days or 20 days. It is also your experience in your plant, how frequently you have to do. So you need to develop your own. Mounting in low vibration position. I have seen many of the installation which is in duct or somewhere, vibration is like this. So light source is here and detector is here. It happens like this. So it will give you data, different data, and you will feel like there is a variation, but it will not. It is not the case. It is wrong. Operation maintenance of electrodynamic PM monitors, frequent cleaning of electrode is required. We talk a whole lot about the certification. So when we do all those certifications of the equipment, so as I said in the beginning that we take 6 months to 30 months, like depending upon the performance of the equipment. So longer the tests are required to be done, it gives more confidence of the equipment's response, equipment's behavior. So when it is done, the certification is done, it also gives with the manual that this particular equipment requires calibration after this interval. So if you see in the table, field test which has been done with that equipment for 3 months is said, okay, maximum allowed maintenance interval for that particular equipment is 1 month. If you go to see the bottom one, the field test which has been done for 24 months, for longer time, confidence is more, it said you can do maintenance calibration for interval for 12 months. But it is not written on the wall. It depends upon how you do the operation, how clean your operation is, how well you maintain that. For check of the opacity meter, there are opacity cartridges, filters. So sometimes to calibrate, to check that, not to calibrate, to check that, they put that filters in front of the screen, and there is these cartridges or filters of a specific opacity. So they put it for that particular 75% opacity, and if your equipment is reading that, it means that it is working perfectly fine. If it is not, if it deteriorates to a certain extent, then you have to recalibrate and clean it. So this is used. If the misalignment is there, then you have to take out and align it again, figure out what are the problems, and then put back in there. So you have to figure it out. You need to understand it generally doesn't happen, but if it happens, then you have to do that. Some of times you have the cleaning problems. This is kind of forward or backward schedule like this you find. You have seen the cover, dust particles settle on that probe. You keep cleaning it. Over the probe, it is not affecting because monitoring is not on this. Monitoring is in between this portion, right? So light source goes from here and reading is happening here. So we have the ideal condition. We should keep it clean for sure. It is not like that monitoring is not happening here, so leave that. So, but you should have. So this portion should also be kept clean. So there are sometimes blower is there to have a continuous air or some other kind of cleaning. With it you figure it out, you understand how much time you take, what interval you have to keep that cleaning. So you need to require that cleaning as well. Thank you very much. Questions, please. You can directly ask the vendors as well. But that is inside stack, temperature doesn't affect upon the ambient air quality, no? You have a temperature of the gas which is coming from the combustion section, boiler. That doesn't affect from the ambient air quality. But sir, boiler temperature is 1200. So that is changing, that doesn't depend upon what will happen in your boiler is if the ambient condition is that humid, it will affect your coal quality or moisture in the coal. Accordingly, you operate, you change the condition of the combustion condition. So that will not have change any change in that. How to maintain stack temperature? So that is the operation question. You have to maintain the gas temperature depending in your control room. You have to increase in that. That directly depends upon combustion condition in your boiler. Stack will take just gas coming out from the boiler. So that is your job to operate your boiler. SAMS will not do anything in that. Velocity? air velocity, air coming from your boiler. Of course. So you, uh, when you monitor, so when you report, you also give that your air, which is the flue gas which is coming out, has a certain speed. It should not be exceed too much. Yeah, 12 meter per second or 14 meter per second, 16 meter per second. That is fixed. That is the operational part. You cannot change that. Otherwise, your entire boiler operational parameter has to be changed. Velocity will certainly change. So simple thing is, if your velocity is increasing in the flue gas, it literally means your airflow in the boiler is higher. So your worry of having the right equipment is pretty small. You are losing your energy from the boiler because you are giving more air, you are diluting more. So it will have more energy coming out through the stack. So that's a very major problem. You can cover many equipments with that energy. So there, your operation of the boiler is more critical compared to that. You cannot have more than that, otherwise there will not be complete combustion. Your CO will also increase because air of flow is too high in that, or maybe temperature will not be in the balance. Energy, you will lose energy most of the time. Sir, equipment providers can directly how is equipment
As and when technology is improving, you get instruments which can give you an confirmation that the contamination crossed certain level, and until certain contamination level it can correct itself. And if there is a misalignment, either you get an alarm or there are instruments which do a misalignment also. It can align by itself. They call it as auto alignment. So that is also possible. That is available in the market.
not with every equipment, so that you have to figure it out. Yes. सर लाउड लाउड कल का एनर्जी खत्म हो गया लगता है आपका
Sir? No sir, reading में difference नहीं आएगा until otherwise you don't dilute the sample. आपका हम लोग ज़्यादा zinc कितना और सी कैपेसिटी क्या फ्लो रेट में देना चाहिए वो स्पेसिफाई किया हुआ है. हम उतने तक यूज करेंगे तो कोई तकलीफ नहीं होगा. सर ब्लोवर नॉट रिकमेंडेड जनरली नहीं है. ब्लोवर इज हाईली रिकमेंडेड देयर इन इंस्ट्रूमेंट एयर बिकॉज इंस्ट्रूमेंट एयर is coming from an high pressure to low pressure, so there will be in cooling and your flue gas has a lot of moisture, so that will create an moisture, right? Slowly fill सा form होता है आपका lens में, and there are some instruments which are coming with an heater, right, onto the lenses, which will avoid some dampening forming on it. So there are various topics to it. Blower is generally recommended because it keeps running. Instrument air, we don't even know if sometimes the line is blocked and other thing. The instrument air will not go to the dust monitor, and then we will not even know. Then you will have more lines coming to you telling you instrument air is there, not there. Then those type of diagnostic feature also you will have to adapt.
Sir.
It is the ambient, right? Yeah. That is why there are blowers which are available with heaters, just to make sure that they don't condense. We cannot remove the moisture, only to make sure that it is not condensing there. And all whatever we are giving, this is a curtain. Why? Don't allow the flue gas to come and deposit the dust onto the optical surfaces. उतना एक curtain बनाना है. We are not going to put a huge amount of air or anything into it. We are just making sure that it is slightly positive, than the flue gas pressure, so that it forms a curtain and gives you a longer maintenance period. It cannot eliminate everything, it only increases your maintenance period. सर प्लांट रनिंग कंडीशन में रहेगा तो सर जीरो कैलिब्रेशन ओपेसिटी मॉनिटर को हम लोग जीरो कैलिब्रेशन बोलते हैं ना. Calibration, there are one is adjustment, one is calibration. Calibration is always done only within standard reference method, that is called calibration. And वो हम लोग आइसोकिनेटिक सैम्पलिंग से ही कर सकते हैं. उसी के पहले उसको जीरो एडजस्ट करने के लिए आपको इसको निकाल के एक डस्ट फ्री एनवायरनमेंट में, मतलब ये हम समझ लेते हैं ट्यूब, राइट, उसके अंदर काला कोट किया हुआ, नो रिफ्लेक्शंस, उसी में फिक्स करके जीरो करना पड़ता है. दिस इज हाउ एन ओपेसिटी मॉनिटर का जीरो हो सकती है. उसी के अलावा देयर आर सर्टेन इंस्ट्रूमेंट्स व्हिच आर अवेलेबल व्हिच कैन स्विच ऑफ द लाइट, राइट, एंड टेक द एम्बिएंट व्हाटएवर द लाइट इज देयर एंड देन मेक अ जीरो ऑफ इट. वो भी पॉसिबल है. सो देयर आर चेक साइकिल इंस्ट्रूमेंट्स इन इंस्ट्रूमेंट. नहीं, शटर का टॉपिक ही नहीं है इसमें. इसमें है उसका लाइट, इनबिल्ट लाइट है ना, लाइट सोर्स, उसको बंद कर देते हैं, उसका पावर बंद कर देते हैं इंटरनली. उसका एक जीरो चेक साइकिल बोलते हैं. उसी में क्या है, उसको जीरो लाइट बंद कर दिया तो इलेक्ट्रॉनिक्स में जीरो लाइट कैपेसिटर होते हैं ना, तो कभी भी डिटेक्टर्स रहते हैं ना, वो लाइट को डिटेक्ट कर रहे हैं. और कभी कभी वो लाइट नहीं है तभी भी वो डार्क करंट क्रिएट करता है, उसको ही हमको जीरो करना पड़ता है, राइट. वी आर टॉकिंग अबाउट ड्रिफ्ट. जीरो एंड स्पैन किसके लिए कर रहे हैं, वो ड्रिफ्ट हो गया, इसको करेक्ट करने के लिए कर रहे हैं. तो इसलिए क्या करते हैं, उसको लाइट को, सोर्स को बंद कर देते हैं, फिर डिटेक्टर कुछ भी लाइट देख रहा है और कुछ सिग्नल दे रहे हैं, उसको जीरो कर देते हैं. सो दैट इज व्हाट इट इज कॉल्ड एज ऑनलाइन जीरो. और डस्ट मॉनिटर्स में ये फंक्शन रहता है, इसको चेक साइकिल भी बोलते हैं. सर वो इंस्ट्रूमेंट की इनबिल्ट कैपेबिलिटी है सर. वो तभी स्पैन भी चेक होती है. तो एक 0 पॉइंट की चेक हुई तो उसके बाद स्पैन पॉइंट की चेक होगी. तो उसमें क्या है, आपका लाइट का इंटेंसिटी को 70% कम कर लेंगे तो डिटेक्टर का भी कैपेसिटी पता चलेगा. तो बहुत कम हो गया तो आपको मेंटेनेंस रिक्वायरमेंट की अलार्म आएगी. और उसमें भी उसका 70% से नीचे और भी नीचे चला गया तो आपको मेंटेनेंस रिक्वायरमेंट का अलार्म आता है.
सर सर जनरली सर क्या होता है, जैसे कोई रनिंग स्टैक है और उसमें सर अपनी वो बोला क्या कहते हैं शट डाउन हो गया, वो लाइन बंद होगी, तो उसमें सर क्या होता है, जो लास्ट जो अपना सिग्नल है, जैसे पकड़ लो 4 मिलीग्राम वो है, वैल्यू क्या करता शो करते रहता है, मतलब तो उसको हम किस तरह से कर पाएंगे.
जैसे नहीं समझा आप, ये हो चुका है,
हाँ
राइट,
अभी रनिंग में था, बंद हो गया,
बंद हो गया. और इंस्ट्रूमेंट है तो डेटा.
हाँ हाँ सर, वो जनरली सर क्या होता है, ही टेक्स 4 to 20 मिलियन सिग्नल लेते रहते हैं. हाँ हाँ 3 to 4 दिखाता है. हाँ हाँ लगभग सर. सर सर एक और चीज़ था सर, जैसे अभी गाइडलाइन में सर बोला है कि आपको जो है जीरो चेक करना है, डेली करना है, और स्पेसिफिक टाइम भी दिया है 10 AM का. तो सर अभी जैसे पकड़ लो कोई अगर एक लाइन है, एक क्लियर है तो उसके लिए पॉसिबल होता है। जैसे पकड़ लो मल्टीपल लाइन से, 3 लाइन से, 4 लाइन से, तो उसमें सर कैसा एक इंजीनियर हाउ विल ही इंश्योर एट 10 AM टू सेट 0, मतलब ये पॉसिबिलिटी नहीं है, वो लिखा तो है। या। तो सर उसके लिए फिर कुछ ऑटो कैलिब्रेटर टाइप कुछ अलग से आता है मेरे ख्याल से, क्योंकि जनरली अभी जो हमने जो देखा है जो ऑटो अलग है, वो अलग है। हाँ हाँ। वो मुझे सही है। हाँ असल वो खुद भी करता है, और उसमें सर क्या होता है वो कलर कोड भी आता है उसका, येलो वाला, येलो येलो में जैसे दिखाता है तो वो मालूम पड़ता है कि वो आपका 0 हो गया है। हाँ
Hello. Hello.
hello, 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 hello. हेलो हाँ हाँ हेलो 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 चेक हेलो 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 चेक
तू कनेक्ट कर रखा है? हेलो हेलो चेक हेलो और बिसिल कम करो हेलो 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 चेक हेलो हेलो वो बढ़ाओ हेलो हेलो चेक हेलो हेलो चेक हेलो 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 चेक हेलो 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 टेस्टिंग हेलो 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 टेस्टिंग हेलो 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 वो बड़ा जरा सा हेलो 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 हाँ बस रहने दो हेलो 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 टेस्टिंग हेलो 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 टेस्टिंग हेलो 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 टेस्टिंग हेलो
हेलो चेक चेक
हाँ नहीं डिलीट कर दो
Look into gases, technologies available, instrumentation available, detection. We're going, okay, what measure? Where do we want to measure? Why at all a gas analysis for SEMS or for process? Sample handling for extractive detection technologies, and then probably the more interesting part, what are the advantages and disadvantages of the different technologies. So you have seen that one yesterday already. That is the legislative monitoring. That is what we are talking about when we talk about SEMS. The other gas monitoring locations or positions in a power plant or in processes are process related measurements. So what is it what we are asked for monitoring? It's particulates. It's the particulates. Opacity tells us how visible various kinds of or emitted from an emission source. The organic compounds, total hydrocarbons, and dioxins, furans, primarily when I'm in a waste incinerator or waste to energy plant. There I'm creating dioxins and furans, and they might to be detected. Humidity, gas velocity, or normalize our data, what we are monitoring, what we are creating, and possibly also detect. For example, need if we go into carbon trading, output. If we go into PM trading, we need our total PM output. Okay, why at all monitoring? Reason for monitoring to do that. Reason for monitoring is we want to control our emissions,
And in order to know how good our control mechanism works, relations, we had that two ways, two approaches, US approach and European approach, with US EPA 40 CFR 60, 40 CFR 70 and ASTMs. No type approvals, we heard that also from Kanan Sir this morning, and we heard it yesterday, and very extensive site testing after installation, so installation testing. Europe, we have the different regulations, European regulations as well as country-specific regulations. The country-specific regulations are allowed to the European regulations. Stringent. In Germany, we have, as an example, it's based on TA Luft, that means technical air. Then the emission law and the emission regulations, and presently we are at number 44. So the emission regulations are for different industries and define the requirements and the emission limits, etc. for the only type approved instruments. Testing after the installation, which is to some extent now. Why gas analysis? When we look into process, we want to optimize requirements, we want to make better product, it's a safety issue. That's all the things which are it's the requirements laid down in our for cleaner process. It gives better transparency of what we are doing. Yes, we also want to avoid fines. So that's because if we go over the emission limits, then there might be fines. And in some countries, it might lead even to switching off the plant or reducing the plant output in order to comply. And we do carbon trading, or we do PM trading, as it is done here in the US, in India, sorry. And process monitoring, very clear. Investment is there. Monitoring. If I take away that avoiding fines, then pure emission monitoring has no return on investment. We have to be very clear. It's a cost factor for the industry. unless we can take the data we create and link them to process conditions, link them to optimizing our burners, our boilers, our energy supply, unless we can do that. Again, environmental monitoring is a cost factor for the industry. Should be very clear about that. But it's not only the monitoring which is the cost factor, it's the overall lifetime of the equipment what is the cost factor. And that there goes service maintenance requirements for maintenance very well into it. So, initial cost is one thing, overall cost of lifetime is the more important one, and we should consider that as a decision factor. So, what I'm doing here is talking about the L1 principle. I go for the cheapest equipment. Cheapest equipment normally is the most expensive on over lifetime. Very clear. And that goes for all manufacturers. So, what do we want from our analyzers? They should be sensitive, they should be stable, they should always work, don't need any maintenance. They should work in all detection concentrations from the low ranges up to the very high ranges. Maintenance, no. Maintenance, we don't want to do that. The analyzer should not need that. I can tell you one thing. I guarantee you, regardless what manufacturer, every instrument requires maintenance and service. Or have you seen a car which does not require maintenance and service? Analyzer is not different. Our system, the overall system, should be easy to be installed, should be well designed, well engineered, should have, of course, like the analyzers, a long lifetime. Canon sir said this morning 10 to 15 years, I completely sign under that. And we should have good data availability and connection of the data with data backup. We had that also heard that this morning. If we think about extractive monitoring systems, there's something missing. No? There's something missing here. What do you think? How do I get my gas sample to the analyzer? How do I condition it? How do I transport it? My sample handling system, sampling and conditioning system, that is the key to an accurate Canon is not it. Gas analyzer, a wonderful gas analyzer is a piece of cake. Because I do that in the should also work in more or less almost very good conditions, probably not lab conditions. But the sample handling system, that is directly connected to your process, and that is a specific thing which needs